In this video, we'll be looking into the third module, that is Agile Development and Principles that guide the practice of SCPM, Software Engineering and Project Management subject. So starting with the first chapter, Agile Development, we have our first topic, what is agility and what is the importance or what are the aspects of agility. So we can say that agility in SE, Software Engineering, refers to ability of development team or process to swiftly and effectively adapt changes in the requirements, technology, and team composition or the other project factors. How will this happen? This approach recognizes the dynamic nature of software development and enables flexibility, collaboration, and rapid delivery to meet the evolving needs. So compared to our traditional methods, agile development offers upper hand. Okay, so we'll look into what are the aspects. So rapidly respond to the changes in the requirements, technology, and team composition. Along with that, we also deal about collaboration and communication among the team members. So this also includes customers as a part of development team for better alignment. So when customer is always available with the team, it will be easy for the team members to ask the customers or show him or her whatever the updates or the products which are created on a regular basis, on an iterative basis, and get immediate outputs and work on it. So it emphasizes rapid and incremental delivery of operational software. So that's what I told. And adapt planning to accommodate uncertainties in project. So it also deals of having plans to accommodate uncertainties. When uncertainties, errors occur, how do we deal with them? So that is what we'll be discussing in agility. So as a project proceeds, the cost of change increases exponentially. Suppose you started from communication and then completed all the 4 stages and then reached the deployment stage. After deployment stage, when when the stakeholder reviews this process, he says, ಅಯ್ಯೋ ಅದು ಗ್ರೀನ್ ಕಲರ್ ಬದಲು ರೆಡ್ ಕಲರ್ ಇರಬೇಕಾಗಿತ್ತಲ್ಲ ಅಂತ ಹೇಳ್ತಾನೆ. ಸೊ ಅವಾಗ ಯು ಶುಡ್ ಗೆಟ್ ಬ್ಯಾಕ್ ಅಂಡ್ ಡೂ ದ ಎಂಟೈರ್ process again. But then, yeah, that's what. As the project proceeds, the cost of change increases exponentially. Agile practices like incremental delivery, continuous unit testing, and pair programming contribute to flatten this particular cost. So if you consider the project and cost curve, it increases exponentially. But then by making use of Agile, you can flatten this. Cannot minimize this completely, but then you can flatten this by using these methods, that is unit testing, pair programming, and incremental delivery. So this was about agility. If they ask what is the definition of agility, what are the factors of agility, idella baribekagutte. Okay na. Next we have the agile principles. There are 12 agile principles. This is a short question which will be asked in exam. So you should remember these 12 principles. Firstly, we should make sure that early and continuous delivery of valuable software. Then changing requirements, we should embrace whatever the customer says. At any stage of development, customer says change this, we should be ready to accept it and work on it. Okay, so that's what second principle says. Third one says is we should give frequent delivery of working software. So instead of providing excessive documentation, if you make use of working software, it will speak louder than the documents. Then we have the daily collaboration with business people and developers. So that's what we have discussed. So involving customers as a part of development team helps us to align better with the requirements and then work towards efficiency. Building project around motivated individuals. And then sixth principle is face-to-face conversations. So face-to-face conversations are the best ones to communicate with the teammates. By doing so, we can interact properly, rectify the errors on the spot, and it is effective in all the terms. Then we have working software. Working software is the primary or the priority measure for progress. So if you have a working software, it means that you have reached to some extent of the completion of your project. And then we have sustainable development, that is to maintain a constant pace. Then ninth principle is continuous attention to technical excellence. So we should thrive to technical excellence with each iteration, with each incremental delivery. We should make sure that the product is developed or advanced in the next incremental process. Okay, then we are maximizing work through simplicity. So we should make sure that the work which we are dealing is simple. By keeping the work simple or the process simple, it makes easy for the stakeholder as well as the teammates to understand what they are actually working upon. So yeah, that's what 10th point speaks of. Second, encouraging self-organizing teams. By having self-organizing teams, the like-minded individuals can come together and work on a product. When like-minded individuals are working together, they'll have better communication, better collaboration. With better communication, collaboration, you can deal or do the work quickly. So that is what 11th point says. 12th is regular reflection and adjustment of team behavior to improve effectiveness. So by having the regular technical reviews, the team introspectives, retrospectives, we can make sure that the team efficiency is improved. Coming to next, we have human factors. So in agile development, human factors play a major role in project success. So we'll look into the factors one by one. First one is competence. That is, team members should have necessary skills, knowledge and talent to do the assigned job properly. Then we have collaboration. So by collaborating, we can lead to efficient, effective teamwork and communication between our peers. Between our teammates. Then we have decision making ability. When you're working in an agile team, you have all the rights to take own decision and then work on it. So that's what decision making ability speaks of. Fuzzy problem solving, that is, team should be comfortable with ambiguity and adaptable to the change. So whatever the changes come, whatever the problems come, you should be ready to solve it or adapt it. Okay, then we have mutual trust. So mutual trust is pretty important and respect is pretty important in order to have a supportive and productive environment. Only when all the employees in a team are happy and they get proper respect and have mutual trust on their teammates, they can work properly. Next, we have the self-organization. That is what we have discussed. So teams should do their work, processes, schedules independently for increasing the efficiency. So this was about agile principles. Firstly, speaking of agility, that is, it could be asked for 4 marks. Agile principles could be asked for 8 marks. This could be asked for 3 marks or 4 marks. Next, we have extreme programming. This is short a 10 marks question. So extreme programming is a software developing methodology under agile development where we emphasize on iterative and incremental development. So you are iterating and incrementally developing by having continuous feedback, flexibility and customer collaboration. So the practices here are test driven development, pair programming, continuous integration, simple design and so on. So next we have XP values. So there are 5 core values. Okay, so in order to remember these 5 core values, write it as CR, FSD. Write this D as C. So C stands for communication. So communication plays a major role in the extreme programming. That is, once you communicate with the teammates, it will be easy to put forth your ideas or the requirements in terms of, so if you're speaking from the stakeholders perspective, communication is pretty important for the stakeholder, right? So only if he says or put forth his ideas or requirements properly, that's when we can move further, right? Not just with the stakeholder, also with the teammates, communication is pretty important. Then we have the respect. Yeah, mutual respect, respect among the team. All the teammates are important for having the healthy, supportive and productive environment. So communication, respect, and then we have feedback. So feedback should be generated by the software or by the customer or by the other team members also. So as and when we get continuous feedback, we can iteratively work on it and come up with better solutions. Then we have simplicity. Simplicity is the developer should design only for the immediate needs rather than considering the future needs. So in that case, we'll be coming up with a simple design that can be easily implemented in the code. Further, if it is implemented and when we take the feedback from customer, if it is accepted, we can move on to developing the code further. Then we have the courage. So courage here, XP practices demand courage because discipline should be there among the team members to design properly, work properly, maintain sustainable working atmosphere in and around the team. So that's what XP value speaks of. CR, FSD, remember it. Next we have the XP process. So in XP process, there are 4 activities. So this diagram has to be drawn. So one thing in FSD subject, in SCPM subject, most of the questions or the topics are theoretical. We have a diagram and then theory. Make sure that you cover the diagram half a page and then again rest half of the page fill content, and if required, if it's a 10-mark question, then make sure that the side portion is also filled. Along with that, you should make it must to highlight or underline the important key points, because externals, because the evaluators, they won't read each and every line what we have written. Okay, so they'll just look into the important, they'll just look into the highlighted key points. If they feel that whatever key points we have highlighted are sufficient enough, then they will allot us accordingly marks. Okay, so highlighting is pretty important. These keywords should be there. If you don't know what is inside those keywords, fill something, but then keywords should be there. Okay, so next we'll look into the XP process. So extreme programming uses object oriented approach as its preferred development algorithm, and it has a set of practices that occur within the four framework activities, from four primary activities. So those activities are planning, designing, coding, and testing. So we'll start, we'll read this part. In above X cycle, planning, designing, coding, testing are continuously iterated upon. They are continuously iterated upon, and with each iteration contributing to incremental development and refinement of software product. The same thing we have been reading from past 3 modules. Further also it is the same. Incremental approach, with each iteration you should make sure that there is incremental development and refinement of the final software product. So it allows rapid adaptations to changing requirements and ensures high quality software is delivered. So next we have the planning part. So in planning we have planning activity begins with listening. So you should firstly listen to your customers, your stakeholders. So they'll tell what are the requirements and all. So in planning, under planning, we have the user stories, iteration plan, and values. User stories, from the requirements, you generate user stories, and along with that, you also generate values there. Now you'll plan the iteration. You look into the iteration plan. How should we proceed with this particular project? Now that we have got the requirements, we have got the technical details, how will we proceed with it would be discussed in this particular activity. So in planning, there are 3 types of planning. One we have is release planning. So in release planning, the team decides the scope and priorities for upcoming release. So next week we have to release this particular feature. So this feature is taken from, again, the user stories only. From user stories, the features would be prioritized, right? So depending on those priorities only, we'll discuss upon the plannings, the release plannings. Then we have the iteration planning. So each iteration involves detailed planning where the team member selects the user stories from the data, from the requirements to implement and commit the completion within the stipulated time. So that is what iteration. So in one iteration, you are performing one activity. Another iteration, another feature is delivered. Then we have daily stand-ups. Daily stand-ups happen for 5-10 minutes where the team discuss about the daily growth, daily progress, what are the activities they did daily, what are the obstacles they faced daily, and how did they overcome that. So that was about planning. Next we have design. So in design, further we have 3 types of design. Once planning is done, all the prerequisites are ready. Now those prerequisites should be considered and designed. Okay, in design we have 3 types of design. One is incremental design. In incremental design, first you start with planning, then design. You design a particular feature, you complete it, and in next increment you again either enhance, either upgrade that particular feature or move on to the next feature. So that is what incremental design speaks of, where gradually based on the changes and the requirements or the feedbacks given from the stakeholder, you improve or upgrade or come up with new designs. Okay, that is what incremental design speaks of. Next we have the simple design. In simple design, we tend to keep the design as simple as possible so that the customer can understand and tell what should we do further. Once the customer understands and tells what should we do further or proceed with it, we can further develop the proper design, the complex design, including all the technical aspects and all. Then we have refactoring. Refactoring means we should make sure that everything is clean, maintainable, and adaptable. Next we have refactoring. Under design we have refactoring means when the customer says particular updates or changes should be made to the requirements, then we have the design should be capable to refactor. That is, it should be maintainable, adaptable, the code base should remain clean, and it should be easy for us to refactor it, change it. Okay, so that's what comes under design phase. So this designing is done by the mediums of spike solution prototypes, we use of simple design CRC cards, and so on. Next we have the coding as the third activity, where we perform like firstly we have pair programming. So in pair programming, we have a team of two people. Okay, the individuals are grouped into pairs. So it could be like one person is writing the code, other one is testing, or one person is writing the code, other one is providing feedback, one is the business person, other one is manager, or it could be vice versa, such that the task or the job should happen quickly. That's why we are pairing two people. By enabling pair programming, we can enhance the code quality. Also, there is knowledge sharing happening between the teammates, right? And then even the problem solving capacity would increase. Then we have the test driven development. So in this, developers write like automation tests before implementing new functionality, so that we can check if the code meets the requirements and remains proper after testing or not. Then we have continuous integration. In continuous integration, code are changed, like code changes are incremented, like integrated frequently in a shared repository with automated builds and tests executed to detect integration issues early at the initial stage itself. We can detect. Then coming to fourth activity. So this coding is done through pair programming, continuous integration. Yes. Then coming to next, fourth one we have is testing. So in testing, it is the step done before deploying it to the customer. So in testing, we have unit testing. Unit testing means we write unit tests to validate individual components or units of code, or it could be a function also. We test the functions, we test the units. That's why it's called as unit testing. Acceptance testing is tests are based, like they are defined based on the user stories to verify that implemented features meet the customer expectations and acceptance criteria. Then coming to exploratory testing, here we explore the system software dynamically to uncover whatever the possible defects are, whatever the underlying issues or unexpected behaviors covered by the automation testing. So testing is done by unit and acceptance. And once this is done, once the entire cycle is completed, once we come to a situation or a condition or a place, once we come to a stage where we feel like the requirements have been met and we have come up with a final product, that's when release comes. That's when we release the software to the user. This software is again incremented. The project is again it gets updated. Okay, so that was about XP process. This is a pretty important question from third module. I would say you should definitely study this, understand this. Yeah, to summarize up, X process has planning, design, coding, and testing as the four primary activities. Next, we have the adaptive software development. Adaptive software development, by definition only we can understand. So we are adapting to the different changes which are happening. Okay. So it is a methodology focusing on human collaboration and team self-organization to build complex software and systems. So its philosophy emphasizes agile, adaptive development through collaboration, seen as source of order in complex interactions. So there are three phases in this SCL, that is speculation, collaboration, and learning. So speaking of speculation, this the project is started at the speculation part. So it conducts adaptive cycle planning based on the project initiation information. So with the information provided, it starts the conduction of adaptive cycle planning. So the project is started, conducts adaptive cycle planning based on the input which is given. Then this planning defines set of release cycles required to the project. So considering customer mission statement, project constraints, and basic requirements. So we'll discuss about the release cycles. So speculation decides, okay, 5 cycles should be there. In each cycle, one functionality should be released. So that's what speculation speaks of. Then we have collaboration. In collaboration, multiple team talent and creativity beyond individual contribution. So beyond individual contribution, when the talented individuals come together, it leads to team talent and creativity, enhanced team talent and creativity. So communication, teamwork, and individual creativity are pretty important for collaboration. So in this, trust is also crucial. So that is, team members should be able to criticize. Criticize means wherever you have done a mistake, I should be confident enough to say, okay, you're wrong at this point. You can rectify it here. And then assist, that is, if you have done mistake here, I'll help you out to solve it. Then work diligently, that is, work in harmony. And then possess necessary skills and communicate properly. Possess whatever the skills required are and communicate properly. Then last we have learning. So in learning we have focus groups, technical reviews and project postmortems where we deal about the loopholes whichever have occurred, and then we start learning, we start reviewing and come up with better solutions. So that's what comes under learning. So in speculation, we have the mission statement, basic requirements, time-based planning. Here all the project starts, and then we come up with adaptive cycle planning where we specify how many cycles should be there, and in each cycle what activity, what functionality should happen. Next we have collaboration. In collaboration, requirement gathering is done, many specs, that is specifications are dealt here. So in collaboration, team members should come together, trust, communication, teamwork, all of that. Then we have learning. In learning, components are implemented, tested, focus groups for feedback, technical reviews and all that should be done. So adaptive software development, ASD, could be asked for 6 marks or 8 marks. Let's move on to the next topic, that is FDD, feature driven development. Either ASD or FDD, one among them would be asked. Okay, so in FDD, it is adaptive agile process model enabling collaboration, feature driven decomposition and communication of technical detail. So feature driven development, you are making use of features, and depending on those features you are performing, the development happens. Okay, so FDD prioritizes software quality assurance through incremental development. So software quality is the utmost priority here. So it is maintained through incremental development, design, code, inspection, audit, metrics collection and pattern application. So in FDD, feature is client valued function. So it is implementable in 2 weeks. So a particular feature, let's say the login page is a feature, right? So this login page should happen in 2 weeks itself. It is a tiny task of the entire YouTube application which we are building, right? So here we are defining the features. By defining the features, it offers several benefits, that is ease of description, organization into business related groups and regular development of operational features every 2 weeks. So as we keep on developing features, this 2 weeks, first 2 weeks we developed one particular feature, next 2 weeks again we come up with one particular feature. As and when the feature is developed, we take continuous feedback from the stakeholder. By having continuous feedback from the stakeholder and regular inspection of the features, we can rectify whatever the changes need to be adapted and come up with better and efficient product. Then we have features, small size lets effective inspection and drives project planning, scheduling and tracing based on features order. So again, as we have discussed, there are different orders of features. So only the first feature for login application would, for YouTube application would be login. After that, we can think of other features. So here indirectly we are providing a hierarchy of features. Okay, so we define these features using template. So this template will have action. What is the action to happen? What is the result? And what are the objects specified? So this feature, FDD, feature driven development, has 5 steps or 5 activities. So in first activity, we develop the overall model. We establish or describe the overall model as like we don't specify everything here. We provide a vague, like YouTube model ಬೇಕು ಅಂತ we specify here. Then build feature list. In YouTube model, what are the features you want? One login page, and other one the search engine, and then like creators could be able to add and then attend live sessions, and all of that are the features. Now again, prioritizing the features, plan by feature. So like a development plan should be laid out by to set the feature owners. Okay, then we have the design by feature. Here it is a design package which happens in sequences. So you design a feature, you take there is feedback coming, you work on the feedback, and then you again develop it, keep on developing it. That's why the sequence is depicted here. And then build by feature. Once the feature is satisfied, once the client value function is completed, you keep it aside and then look into building the feature further. Okay, next, FDD provides detailed project management guidelines essential for managing the layer and more complex projects. So FDD is useful for managing the complex projects. So it introduces 6 milestones during feature design and implementation, including walkthrough, inspection, promotion to build, ensuring proper scheduling and progress tracking. So this was about FDD. Next we have Scrum. So Scrum in Agile software development, Scrum is an Agile software development method that was convinced by Jeff, this person, in 1990s. So Agile principles are consistent with Scrum principles are consistent with Agile Manifesto and are used to guide development activities with a process that incorporates following activities. So the following activities are, firstly we do the requirement analysis, then design, then evaluation, and then delivery. So within each framework activity, work task occurred within a process pattern is called as sprint. Okay, it's called a sprint. The work conducted within a sprint is adapted to a problem at hand and is defined and often modified in real time by the Scrum team. So a particular activity which you select, a framework which you select from the framework, you select a particular activity that is called a sprint. Now this sprint is solved by a Scrum team. Okay, a Scrum team will take up this particular sprint and then they'll solve it. So overall flow of Scrum process is depicted here. So we have the Scrum backlog here. Scrum backlog is like a prioritized list of the project requirements and features. Okay, it will keep track of all the project requirements and features with business value to the customer, from business value to the customer perspective. Okay, and then we have the product backlog here. Again, it also keeps the like it is a list which keeps the contents of all the functionalities which has to be developed. And then you load one by one. You keep on loading all the requirements here. So once a requirement is loaded, it will go through the Scrum. That is within 30 days that requirement should happen. Okay, Scrum it happens in 30 days. And looking at the definition of Scrum is a 15-minute daily meeting. So team members speak of what did you do in the last meeting, did you have any obstacles, and what will you do before next meeting. So here again we'll have 24 hours, 30 days. In 30 days also we'll have 24 hours. In 24 hours, daily 15-day meeting will be there. So next, after completion of this, after 30 days, we'll come up with a new functionality that is demonstrated at the end of sprint. Okay, so looking at the theory part here, Scrum, we have discussed what Scrum is, that is 15-minute daily meeting, and what are the questions to be asked under Scrum meeting. Then Scrum enables use of set of process patterns that have proven effective for projects with tight timelines, changing requirements, and business cruciality. So each of those process patterns define a set of development actions. That is backlog. We have discussed what backlog is. That is prioritized list. Then we have seen what is a sprint. Sprint is work units that is done in 30 days. Then we have seen what Scrum meetings are. Scrum meetings are 15-day meetings, 15-minute meetings. Then we have a Scrum master. So in a Scrum team, we have a Scrum head, okay, called a Scrum master, who will assign the work and make sure that the meeting, he is the head, okay. He'll make sure that the meeting happens properly. Then we have demos. Demos by definition only we can understand it is the prototype which we come up. So this prototype, we can come up with this prototype in the sprints only. That is before 30 days only. If we come up with a prototype, it will be called as demos. So this demos will be further discussed with the stakeholders, and then the necessary actions would be taken further. So this was about Scrum. Next we have Crystal. So Crystal is a family of agile software development methodologies developed by this person. So it is designed to be adaptable to various team sizes, project complexities, and system criticalness, enabling flexibility and efficiency over rigid processes. If you consider the previous methodologies or frameworks, we have seen that most of them have rigid processes. That is, a set of people should be there. These people should work like this. But then in Crystal, it is not like that. It is flexible, pretty flexible. Depending on the team size, how the project is, and what is the cruciality of the project, we design the framework. Okay, so how it works? So initially we choose the right methodology. That is, we look what are the project needs, and after looking at the project needs, we select the Crystal. So here there are three types of Crystal. Crystal clear means small team, non-crucial project, less than 6 people would be there. Crystal yellow means 20 people will be there, and it is a moderate project. Okay, and then Crystal orange means 20 to 40 people would be there, and it is critical project. Speaking of the second step, after deciding the right methodology, we'll look into the core values, that is communication. We should make sure that communication happens between the teammates as well as the stakeholders. We also look into the frequency delivery, that is, within a stipulated 1 week or 2 weeks, there should be frequent deliveries happening with each iteration, okay, with each advancement. Then we'll look into the reflection and learning. So the main aim of Crystal is that the teammates should reflect upon the mistakes which they have committed and then learn simultaneously. It has to be real-time learning such that you don't repeat the mistakes further, and whatever the mistakes you have done, you have to rectify it. Then we have simplicity. That is, the entire process should be pretty simple and pretty understandable by the stakeholder and the teammates also. Then we have communication and collaboration. So it is pretty important for the teammates to communicate and collaborate. Next, we have communication and collaboration. So it is pretty important for the teammates to communicate with each other, and collaboration leads to teamwork and better understanding between the individuals. Communication should also happen with the stakeholder, and we should make sure that whatever we have developed, the frequent deliveries are communicated to the stakeholder, and the feedbacks are taken positively. Then we have the third, that is team roles and structures. So here there are flexible roles. So depending on the project, on the size of the project and complexity of the project, the roles could be interchanged or allotted accordingly. Then we have team autonomy. So the team is independent enough to work on the project, and the teammates have the authority to take the decisions like unambiguously and work towards completion of it. Then we have adapting and improving feedback. Adapting and improving. So that's what we have discussed. Reflecting and learning, it is the same. If the stakeholder tells that at this particular step, at this particular increment, I'm not feeling it as right, or this changes have to be done, then we should be able to adapt it and improve our project. So that is what it speaks of. Then we have feedback loops and reflection. So it is pretty important to have feedback loops and then reflect it upon our project. So this was about the chapter 1 important topics. We'll look into the chapter 2 important topics now. Here I have chapter 2, that is software. First topic we have is software engineering knowledge. So software engineering knowledge. So a person called Steve told that like there's a distinction between the specific technical knowledge and software engineering principles in his editorial. He told that software engineering knowledge can be divided into two categories. That is, one category is called as technology related development, technology related knowledge, and the other category is called as the software engineering principles. So technology related knowledge may be obsolete within a few years, but then software engineering principles are relevant over time. So they have a larger shelf life. Okay, so these principles form a stable core of knowledge that guides software engineers in their work. So whatever we are studying today, after 10 years also it will be the same. No, it might have been updated, but then the core principles will remain the same, providing a foundation for application and evaluation for various software engineering methods, models, and tools. So this is what software engineering knowledge speaks of. Looking at our next topic, that is principles that guide process. So these principles serve as a guide for any software engineering process regardless of the specific model being used. So Agile says that be agile, that is, follow all the Agile principles, all the Agile Manifesto should be obeyed. That is, emphasize simplicity and local decision making, focusing on economy of action throughout the process. And then we speak of focus on quality at each step. So at each step, the quality assurance should be met. Okay, our primary objective is to make sure that the quality is consistent. Be ready to adapt. So whenever the user says, okay, idu change maadi ant helidre, we should be ready to adapt it and change it in the process. Build an effective team. An effective team would can be only constructed among self-organizing people who are like highly motivated and they are ready to work on it. So in that team, mutual respect and trust should be there. We know that. Establish mechanisms for communication coordination. So by having technical reviews, daily meetings, we can make sure that our teammates communicate with each other and also communicate with the stakeholder effectively to achieve the project success. And then manage the change, that is same as be ready to adapt. Assess the risks. So whichever risks come, we should be able to assess it, come up with a solution. Create work products that provide value. So we should create our final output should be creating a software product that has some sort of value, be it in the market or in general terms. So this is what principles that guide process speaks of. Next, we have principles that guide the practice. So in process, it is the activities which lead to completion of project. But then practice is what we like follow. Okay, what we follow to ensure that the process is completed. So these principles guide the practice of software engineering, ensuring the delivery of high quality operational software that meets stakeholders' needs. So here we have divide and conquer, that is, break the big problem into chunks, solve sub problems, and then combine all the sub solutions to get the initial solution. Understand the use of abstraction. So in abstraction, we are making sure that the project is explained at different levels. By making sure that the project is different levels, we can, if there is any error happening, we can rectify the error, identify the error properly. Then we have strive for consistency. So we should make sure that during the practice, consistency is met. Okay, so there is the code which we design should be usable, familiar to the users. Then we have focus on transfer of information. So transfer of information means we should make sure that communication is proper, and like whatever project we develop, information flow should be system components, ensuring that accuracy, completeness and clarity is met. Then we have building the software that exhibits effective modularity. Effective modularity means we should design softwares with well constrained cohesive modules that are interconnected with low coupling, facilitating maintenance and scalability. Next, we have look for patterns. If there are any common patterns appearing, then you can make use of it, capture the knowledge about effective architectures and foster a shared knowledge, shared language there, and so on. Then we have represent the problem and its solution from different perspectives. Yeah, we have discussed this in the second module also. That is, each stakeholder will have a different perspective. So we have to represent the problem in each stakeholder's perspective and come up with different solutions. Then remember that someone will maintain the software. So we should make sure that future maintenance, correction of defects, adaptation to changing environments and enhancements of capabilities are met. This could be done by by providing documentation also. So this was about principles that guide the practice. Next we have next we'll look into the further topic, that is communication principles. Communication principles is pretty important. It is all these topics are pretty easy to understand. Okay, so first one is listen. So we have to listen thoroughly to the stakeholder, and if I have any doubt, I should ask the stakeholder, and if the stakeholder is telling something, I should not interrupt in the middle. Then prepare before I communicate. So I should make sure that I have a proper agenda to ensure that the productivity is met. I should talk properly with the stakeholders or the teammates also. Then facilitate the activity. So a leader should be there to ensure that communication meeting, to guide the conversation, mediate the conflicts and ensure adherence to the principles. Then face-to-face communication is the best. We have seen this in the principles, right? Face-to-face communication is pretty effective, and we can make use of drawings, documents to enhance the understanding. Take notes and decisions, document decisions. So during communication, it is very important to record all the points which are being put forth in the discussion. By making so, we can have a proper documentation through which we can come up with the further steps. Then strive for collaboration. We should foster collaboration and communication between the team members by leveraging collective knowledge to describe about the product or system functions, fostering trust and common goal. This says that okay, all my teammates have attended the meeting. Now my understanding would be different from my teammates' understanding. In this case, strive for collaboration. When I collaborate with my teammates, it will be easy for me to understand, right? Easy to understand their perspectives also. So that is what it speaks of. Stay focused, modularize your decision. So we should stay focused to that particular topic and maintain clarity. If something is unclear, draw a picture. Draw a picture could be using sketches or drawings to provide clarity when verbal communication is not sufficient enough. Then once you agree to something, move on. So that is, recognize the importance of time in communication and avoid endless iterations by agreeing to move forward even if some aspects remain unclear or not proper. Then negotiation is not a contest or a game. So it has to be a win-win condition, yes, but then you should not you should not get involved in negotiation so much that the stakeholder would be like, this is not proper, and he should not tell. Okay, so that is what communication principles speak of. All the general topics only. If you understand Agile principles and the XP and XP and all the other frameworks, this will be very easy to write. So for each principle, you should write minimum 7 to 10 principles. Okay, how, even if it is of 6 marks also, you should write 7 to 10 principles. Next, moving on to planning principles. How will you plan in a software project? So for planning, we should understand the scope of project. Yes, we should involve the stakeholders in the planning activity. They should be the prime members to sit and discuss with us. Then recognize the planning as iterative. So we should not plan from start to end in one go only. It has to be iterative. So ivattige ish plan ಮಾಡಿದೀವಿ, ish work ಮಾಡೋಣ for this month. Then we'll look into then further planning. Then establish estimate based on what you know. So from the understanding of requirements, we can provide effort, cost and duration estimates based on one team's current understanding of project. Acknowledging the value, the vague or unreliable information leads to equally unreliable estimates. Yeah. And then we have consider risks as to define the path. So when we are defining the path for solving the issue, for developing the program or the project, we should also keep in mind of the potential high impact or possible risks which would come along the way. And we should be ready with the solutions also. Then we should be realistic, that is account for human factors, communication challenges, uncertainties, and inevitability of change when establishing project plans. Then adjust granularity as you define the plan. So even the minute changes, if stakeholder tells no, we should make sure that those changes are inculcated in our project. Okay, and with each iteration we should make sure that the changes are it leads to better enhancement of the project, and ultimately the software, the project is completed and the stakeholder requirements are met. Then we have defined how you intend to ensure quality. If we come across risks, it is pretty evident to define how will you encounter those risks when they come up. How will you make sure that the quality is maintained? So I should like technical reviews or pair programming and all of that. Describe how you intend to accommodate changes. How will I accommodate changes in the team should be described. Then trace the plan frequently and make adjustments as required. So we should keep on tracing the plan every now and then, and whenever the changes are made, we should make the adjustments as required. So this was about the planning principles. The communication principles, planning principles are important. Further, we have modeling principles. Modeling principles is again important topic. So here we'll be discussing about agile modeling principles. That is, primary goal is to build software. Yes, the software should be light and it should contain only necessary models that streamline software construction, avoiding unnecessary overhead. We should strive for simplicity, that our software should be simple. Build models amendable to change. So we should build models such a way that when stakeholder tells change madbeku anta, we should be able to change it. Then state explicit purpose for each model. We should define what is the usefulness of that particular model anta, we should say. Then adapt model to the system. So whatever model we develop should be compatible with the system. Okay, so with the system and the characteristics of the system being developed. Then build useful, not perfect models. So it is always important to build useful models that adheres to the user requirements, not building a perfect model. Then don't be dogmatic about model syntax. So we prioritize effective communication over strict adherence to modeling syntax, forgiving minor syntax errors if the model efficiently communicates its content. Then trust instincts about model correctness. So pay attention to intuitive feelings about correctness of model, even if no explicit evidence supports the correctness. Then we have seek feedback early, that is, take feedback from the customer or the stakeholder and do the needful. Requirements modeling principles. Represent and understand the information domain. So we should represent the domain in which we are dealing, and the information we should understand it. Next we have define the software functions. Yes, define each and every functionalities. Represent the software behavior, that is a detailed explanation of what would happen if we go through the functionalities. Then partition model hierarchically, that is what we discussed previously, like all the functionalities should be provided prioritized. When these functionalities are prioritized, they come under a hierarchical manner. So first, for making YouTube application, first login page should be there. After login page, I should be able to search. All those we are prioritizing it, right? Making a hierarchy of models. Then move from essential information to implementation details. Essential information, like if our project is meeting the required requirements or not, we should start from there to implementation details. Implementation details could be what algorithm we have used, what are the data structures, and all of that. Then design modeling principles. So in order to design the models, these are the principles to be followed. Track design to requirements. We should track the requirements and create the designs appropriately. We should consider the system architecture. So design should start with architectural considerations before addressing the component level designs. Then we should emphasize on data design. We should look into the program flow and ensure that the data structures are like properly used. Then design interfaces with care. While designing the interfaces, we should make sure that they are like properly designed to handle errors, or if they're like in testing also, it should facilitate integration testing for internal and external interfaces. We should prioritize user interface design. So our utmost priority should be user interface design. That is, end user should be satisfied with our product. Okay. Then promote functional independence. That is, we should ensure that the components focus on single functions at that particular time, or sub functions, to maintain cohesion. Then we have minimal coupling. Minimal coupling is keep the components loosely coupled to each other and to the external environment, so that suppose these are the models. Okay, first model, second model, third model. If I say I should add 1.1 model here, that is, it has to be between these two. So minimizing the coupling would help us to delve into the particular models or perform the operations as and when required. Then we have ensure understandable design representations. We should make sure that the design representations are understood, comprehensible by the whoever is writing the code, testers, and in future also whoever will take care of the code, maintenance department and all, they should understand it. Then we have develop designs iteratively. So we should come up starting from the simple design, taking feedback, then again design properly. So by adhering, by obeying all these principles, software engineers can systematically approach modeling tasks, ensuring creation of effective and maintainable software systems. Next, moving on to the next topic, that is construction principles. So in construction principles, we'll look into the coding principles. In coding principles, we have preparation principles, that is understand the problem thoroughly, graph the basic design principles, choose a proper language, programming language and environment. Then we develop unit tests for components to be coded. Then we have programming principles. In programming principles, we follow structured programming practices. We consider pair programming, we choose suitable data structures, design interfaces, and then the logics and the loops should be simplified. It has to be easily understood. We use meaningful variable names and then write self-documenting code. Then after programming, the validation part comes. In validation part comes format the code for readability. We should conduct code walkthroughs, go through the code each line by line and then derive the validation. Then perform unit test and address uncovered errors. Whatever the errors are coming up, we should make sure that they are rectified, and then refactor the code for improvement. If there is any improvement to happen, we should refactor it. Construction, have coding. In construction coding part we have discussed. Now we'll look into the testing part. In testing, what are the testing objectives? Testing aims to uncover the errors in software. A good test case efficiently discovers undiscovered errors, and a successful test case exposes yet undiscovered error. So the same thing they have repeated in 3 sentences here. Next point we have is the test planning. So in test planning, the tests should align with customer requirements and be planned in advance. So planning can start once the requirements and design models are completed. Okay, so these two are understood. We know that. Then Pareto principle in testing. So a significant portion of errors, 80% portion of errors can be traced to a small percentage of program components. 80% of program errors can be solved with 20% of program components. That is, efforts should focus on identifying these problems and testing these suspect components. So that is what this principle speaks of. Then we have the progressive testing. In progressive testing, we begin testing at component level and gradually scale up to the system level. Okay. Then we have the exhaustive testing limitation. That is, achieving exhaustive testing is impractical because there are vast number of path permutations. That is, if you have studied ST, this step would be easy, because in data flow testing, there are different paths, right? There are different paths. V of G value we calculate. The different paths would be there. If we have to reach the end, then there are n number of possibilities for it to happen. That is, we should focus on covering critical program logic and exercising all conditions in component level design. So by obeying all these principles, we can ensure that effectiveness and efficiency of coding and testing processes, leading to creation of reliable, high quality software. So this was about the coding principles. Next we have the deployment principles. Deployment principles means we should manage the customer expectations. It is pretty understood that customer expectations should be managed. Then we have, we should assemble and test the complete delivery package. Once deployment is done for different packages or the models, we should ensure that it is all assembled properly and then a complete delivery package is given. Then we have established support regime. That is, we should plan and establish a responsive support system before delivering the software. That is, we prepare support materials and establish record keeping mechanisms for assessing support requests. Then we come up with provide instructional materials. That is, how to develop the training aids if necessary. If troubleshoot happens, the guidelines and the descriptions of new features. And then we should fix the buggy softwares before delivery. That is understood, right? All the buggy errors should be rectified before delivering the software. Then we have deliver high quality software to avoid long-term dissatisfaction. Yes, this is understood. Then we have the feedback principles. In feedback principles, we should encourage our users to give feedback by taking feedback on reliability, usability and features. By taking these feedback, we can guide the modifications and improvements from subsequent increments. So by obeying these principles, software teams can effectively manage customers' expectations, deliver high quality software and gather valuable feedback for continuous improvement. So here we reach to the conclusion of third module. So I hope all the third module concepts are clear. As I had mentioned in the important topics video, third module and first module are pretty easy because there are a limited set of topics here, and mostly 10 mark question would be asked. So if you have any doubts, do let me know in the comments. Module 4 and module 5 video would be uploaded soon. I would suggest you to go through the important questions video, in which you'll understand and have an idea of what sort of questions could be asked from this particular module. So if you have any doubts, do let me know in the comments and subscribe to my channel. Thank you.